This diagram represents a section of the ileum showing its two walls formed of brush border cells, with digested food passing along the lumen and a blood supply very close. The process of carbohydrate uptake into the bloodstream begins with the active transport out of the brush border cells into the bloodstream. Thus, the brush border cells become very low in sodium compared to the digested food in the lumen. Sodium diffuses high to low from the food into the cells. But interestingly, it also drags or co-transports glucose and amino acids into the cells with it. And this is due to special transporter proteins in the cell membranes. Now, some books describe this as secondary active transport, but I always think this can be confusing because it wrongly suggests that energy is being used in the co-transport process. By now, the cells are now very high in soluble, and the glucose and amino acids now move by facilitated diffusion into the bloodstream for use by the body. The knock-on effect of this is that the high levels of glucose in the brush border cells are continually being topped up, and this creates an osmotic pull on the higher levels of water in the food mass. So water moves into the cells by osmosis, and then again by osmosis from the cells into the bloodstream. Thus, the original sodium pumping has resulted in the absorption of glucose, amino acids and, as we've seen, water by osmosis into the bloodstream. And so the way is now clear for the body to make use of the products by the processes of assimilation. Here's a final snapshot of the processes we've just described.